Good afternoon, everyone. It is obvious that at present many organizations endeavor to reduce the movement time in supply chains and gain competitive advantage. In fact, competition is a key factor to the success of supply chains. As a result of increasing the pressure on supply chain partners to optimize operations, cross-docking is an interesting strategy that can be used to minimize the time and cost in the movement of customer orders. This study has been carried out as a systematic review of literature on implementation of a cross-docking system for a warehouse. I am Neerajie Ahangamage from University of Kelaniya, Sri Lanka. The overview of today's presentation is as shown. You have probably heard of it, but what exactly is cross-docking? Cross-docking is a form of freight movement whereby products from an inbound supplier are distributed directly to the outbound customers with minimal or no storage time. Thereby, cross-docking is a strategy of reducing the lead time between the customer orders. It is different from the traditional warehouse, which acts as a buffer in a traditional supply chain model in order to smoothen the delivery process. However, the advancement of technology enabling real-time information exchange and the analysis has now made it possible to replace a warehouse simply with a cross-dock where products are staged instead of stored, and this new synchronized supply chain model can greatly reduce the buffer time. Now let's go through the process of cross-docking. Cross-docking takes place in the cross-dock terminal, which is a minimal space that consists of the inbound and outbound docks. Once the inbound transportation, such as semi-trailer trucks, railroad cars, etc., has been docked, products can then be unloaded to the terminal. They then can be screened and sorted to identify its end destinations. Afterwards, products will be reloaded to the outbound docks before trucks, trailers, rail cars, or other means of transportation deliver to the customers. The products usually spend less than 24 hours at the terminal, sometimes even less than an hour. Generally speaking, cross-docking helps improve a company's inventory and operation efficiencies. As now the warehouse is replaced by a terminal which requires less facility square footage and bear less inventory management risk, the cost associated will be much lower and hence increase the inventory efficiency. Secondly, since the material will move directly from the inbound docks to the outbound docks with little to no stops on the multiple lanes which provide different automatic verification. For example, in-motion labeling, in-motion weighing, label verification, destination scan, etc. The terminal will provide higher operational efficiency. However, the success of cross-docking relies on the following points. First one, proper implementation of cross-docking operations. Secondly, effective management of operations. The methodology of reviewing literature was started through identifying broad domains of the study. These domains included supply chain management, logistics operations, warehouse management, etc. Then, initial research was started through browsing in databases such as Emerald Insight, ResearchGate, etc. The studies that had been carried out during the period of 1995 to 2019 was identified from the initial research related to cross-docking. From the initial research, 50 articles were selected as the next step from searching through words. These articles were again filtered to 25 articles based on their published date. For the final selection of articles in continuing the study, the factors on cross-docking practices, factors considering the implementation of cross-docking were considered, and the research study has been carried out accordingly. Following are some of the insights from the articles that were selected for the study. In a study which has been done in 2001 by Bell has discussed about the crossdock types. It has mentioned that I-shape is the most effective for smaller crossdocks where there are 150 doors. And also it has mentioned a T-shape is best for intermediate size and for more than 200 doors. Furthermore, a study which has been done in 2004 regarding warehouse operations optimizations has developed an optimal layout by assigning the dock doors. The objective of this model has been to minimize the cost by minimizing travel time and material handling. Furthermore, there are some researches which has carried out related to forklifts. The research which has been done in 2005 has discussed a parcel hub scheduling problem focusing the optimization of freight consolidation of terminals at the cross-dock facility. And also, labor resource management is an important thing when it comes to cross-docking. A research which has been done in 2009 related to the use of labor as proposed to provide the labor hour requirements for operating activities. The proposed model incorporates with a flexible planning procedure which minimizes the total personnel expenses by considering mixing skills and operator skills. The objectives of the study was to identify the concept of cross-docking, identify and analyze the prevailing cross-docking practices, identify the factors to consider when implementing a cross-docking system in a warehouse. From the study that has been carried out, following model is proposed in terms of determining the dock doors and cross-dock shapes based on each cross-dock type. The mentioned cross-dock types were identified through the articles referred. The cross-dock types identified were based on the point of consolidation in the supply chain and the type of inventory in the supply chain. From the model, it is shown that for the types that are based on the point of consolidation, shapes such as ILT are more appropriate. Furthermore, the number of dock doors that can be used in here are between 100 to 200 doors. Also, for cross-dock types that are based on the state of the supply chain, cross-dock shapes such as HEX are suggested. These shapes have been suggested since there are various value-adding activities that carries out when a product moves from inbound door to outbound door. Further, when designing cross-dock facility which has such cross-dock shape, it is suggested to use more than 200 doors in order to maximize the operational efficiency. From this study, it has been presented about the benefits of cross-docking, complexities in implementation of cross-docking, and also the factors considered in the implementation of cross-docking by reviewing the researches. Finally, going through a further study, following further researches are suggested. The first one, analyzing the effectiveness of cross-dock shades with respect to different cross-dock types. And the second one, developing a cost minimization model on implementation of a new cross-docking system for a warehouse. Thank you.